Hey everybody, this is Dr. Nelson. This is a video about something called implicit differentiation. Alright, so right now you have a copy of the notes that complement this video. So kind of follow along, and then there'll be some problems for you to try at the end, and then you can see how you did also. Alright, so before we talk about implicit differentiation, let's briefly go over the rules you've learned so far. Alright, so you've learned something first called the constant rule, okay? And that's useful when you're trying to find the derivative of a constant. So for example, say if we have f of x equals 7, okay, that's when you'd use the constant rule. Alright, then you learn something called the power rule. Alright, this is one that we use a lot. And for functions like f of x equals x to the 6th, alright, that's when you'd use the power rule. Then you learn something called the sum and difference rule. And this is when you kind of use the power rule several times. So say for example if we had the function f of x equals 2x cubed plus 4x. Okay, that's when you do the sum rule. Okay, then you learned about the product rule. Okay, and the product rule would be appropriate for trying to find the derivative of this function. Say if we have 3x squared plus 4 times 2x minus 1. Then you learned something called the quotient rule. And that would be good for a problem like, say, f of x equals, let's say, 4x squared plus 1 divided by 6x plus 5. Alright, and last but not least, you learn this thing called the chain rule. Okay, and the chain rule is used when you have a function like f of x equals x squared plus 7 to the 8th power. Okay, so these are 6 important rules you've learned so far in this course. Okay, and they each have a common theme. Okay, if you notice, and let me actually highlight what we have here. Each one, the f of x that's what you're solving for. Alright, so each one of these, you're trying to solve for the f of x. Alright, and remember, f of x is a fancy way of saying y, right? So for every one of these, the y value is what's being solved for. So the y value is what is being solved for. Alright, so again, we could replace every f of x with a y. So this one with a y, this one with a y, and so on. Alright, so is it possible to take a derivative of a function that is not solved for y? Okay, like for example, this one here, we have 3x plus 5y equals 12. Okay, and notice there's no f of x equals like all the other problems. Okay, so this is when you use implicit differentiation. Okay, and just a key fact, remember, anytime you see dy dx, okay, that's really the derivative of y. All right, so don't forget that. All right, so over here, if you put a big star, this kind of tells you what to do, and I'm just going to show you some examples. Okay, so when using implicit differentiation, take the derivative and then make sure to include a dy dx every time you take the derivative of y. All right, please underline that y. That's key. Okay, and then solve for dy dx. All right, factoring is required to solve some of the more advanced problems. Okay, so let me just show you an example, and let me use a different color here. I'll use black. All right, so here we have 3x plus 5y equals 12. Okay. So what you do is you have to first find the derivative of each part. Okay, so 3x can be written as 3. All right, plus 5y. Well, the derivative of 5y, okay, is 5. So plus 5. But we found the derivative of a y, right? Okay, so anytime you do that, you have to include a dy over dx. Alright, just like it says in the directions, it says make sure to include a dy dx every time you take the derivative of y. Okay? And this is going to equal, well, the derivative of a constant is 0. Alright? So now what you do is you need to now solve for the dy dx. Okay, so I have 3 plus 5 dy dx equals 0. So I'm going to take away, let me use a different color here. I'm going to take away 3 from both sides, just like you'd solve an equation. So now we have 5 times dy dx equals negative 3. Okay? And the opposite of timesing by 5 is dividing. So I'm going to divide both sides by 5. And we get dy dx equals negative 3/5. And that's what we're looking for right here. That's our answer. All right, for this problem we have 4x squared plus 3y squared plus 5y equals 10. Okay? So again, every single time we find the derivative of a y, we need to write that dy dx. We're going to have to do this twice, just like over here for example 2. So the derivative of 4x squared is going to be 8x plus, all right, the derivative of 3y squared is going to be 6y plus, hold on, dy dx, right? I almost forgot. Plus, the derivative of 5y is just 5 times dy dx is going to equal, well, the derivative of 10, it's a constant, so it's going to be 0. All right? Now we need to take away 8x from both sides. So when we do this, we now have 6y times dy dx plus 5 times dy dx is now going to equal negative 8. All right? Now it's time to factor. Okay, so again, we're trying to isolate the dy dx. Okay, so when we factor it, we're going to go from 2 to 1 of these, right? So it's now going to be dy over dx times 6y plus 5, which of course equals negative 8x. All right. Last but not least, we need to divide. Okay. So we're going to divide both sides by 6y plus 5. All right. This will cancel out. All right. So our final answer, I'll put it in red. Okay, is dy over dx is going to equal negative 8 over 6y plus 5. And there's our answer. Okay? All right, so on the next couple pages, there's 3 problems I want you to try. Okay, so I'm going to pause the video. So try the 3 problems, then when you're done, I'll hit play, and you can see how you did. All right, good luck. All right, welcome back. Let's see how you did with these problems, okay? So the first one, we have negative 4x plus 7y equals 18, okay? So the derivative of negative 4x is going to be negative 4 plus, right? The derivative of 7y is just 7, but because we have a y there, we need to include the dy over dx, and that's going to equal the derivative of 18 is just going to be 0, all right? Now we need to isolate the dy over dx. So I'm going to add 4 to both sides. Add 4. So that gives us 7 times dy over dx. It's going to equal 4. And then divide both sides by 7. And the 7's cancel out. And we end up with dy over dx equals 4/7. And that's the first problem. All right, let's take a look at the second problem. Okay, the second problem, we have 5x squared plus 10y squared equals 30x. All right, so again, the derivative of 5x squared is going to be 10x plus, now 10y squared, that we're going to use the power rule, right? So that's going to be 20y we also include the dy over dx. And that's going to equal the derivative of 30x is 30. All right. So next step, let's take away 10x from both sides. So these cancel out. So we get 20y times dy dx equals 30 minus 10x. All right. And then let's divide now both sides by 20y. Divide both sides by 20y. And we end up with dy over dx equals 30 minus 10x over 20y. And there's the answer. Okay. Now this one could actually be reduced. We could divide each part by 10. So technically the correct answer is going to be 3 minus x over 2y. And there it is. Alright, here's the third and final problem. You had y cubed plus 4y equals 6x squared plus 20x. Alright, so again, we have a y here and a y here. So we're going to have to write that dy over dx twice. Okay, so the derivative of y cubed is going to be 3y squared. Okay, so again, dy dx plus the derivative of 4y was 4, and then dy dx. All right, and that's going to equal the derivative of 6x squared is going to be 12x, and then the derivative of 20x is just 20. All right, so now we have our dy dx's, so we need a factor. Okay, so it's going to be dy over dx times 3y squared plus 4. It's going to equal, that's a 4 right there. It's going to equal 12x plus 20. All right, and now we're going to divide both sides by 3y squared plus 4. And divide both sides by 3y squared plus 4 again, right? And we end up with dy over dx equals 12x plus 20 divided by 3y squared plus 4. Alright, so I hope this video helped you understand a little bit more about when you use implicit differentiation. Okay, and so now for the next part of class, you're going to spend some time practicing these problems. Okay, this video is going to be on my website, so if you ever get stuck, you can go back and review this, especially as you prepare for the next test. All right, good luck.